Hi, my name is Floaty Boat, and you're probably here because you want to make a video game, but you don't know anything about programming, and all of the other videos on YouTube tell you to install like 10 million things that you don't know what they are, and are completely unnecessary to get started in game development specifically. So I'm going to show you from some programming fundamentals to getting sort of a game running, just everything from scratch. So if you watch from beginning to end of this video, you should have a lot of the beginning fundamentals of knowing what goes into a game, how much work it's going to take. I'm going to show you some resources you can go to learn more about the specific languages that we'll be using. And yeah, I'm probably gonna ramble a little bit in the beginning here. So if you just want to like skip the code or something, go ahead and do that. It'll probably be a couple minutes of me just rambling about random stuff. um, and then kind of a summary section after the rambling. And so you'll see me make like a folder on my desktop and probably open it when we actually start working on the project we're doing today. Um, so the first thing is a lot of people get into programming to make video games. It's a pretty common thing. Um, but what a lot of people don't realize is that programming is a pretty big undertaking. It's going to take a lot of time and you're going to make a lot of sacrifices in order to become really good at programming. If you are not willing to make those sacrifices, whatever, there are alternatives if you still want to make a game. You don't have to learn how to program. Um, there's like probably the best way that you could make a game without being a programmer is you can get a job and you can earn some cash and you can save up the side cash that you have besides like your rent and all your other expenses or whatever, and you can hire some employees essentially. You can get yourself a programmer, you can get yourself a graphic artist, and like a sound designer, someone to make like your music and stuff. And with those three, you could probably make pretty pretty decent number of games without really needing anybody else. And when a lot of people hear that they need to like hire somebody, they think, "Oh, I need to make a whole company and I need to pay them full time and give them benefits or whatever." Like you don't need to do that. There's tons of places like Fiverr and things, um, where you can just pay people on commission. You just you message them, you say this is what I need from you, and they'll say whether they can do that or not. And so you'll say like, I need a sprite sheet for the main character of this game, and it's going to have like this many frames, and I want it to be in like this kind of art style, whatever. Like, do you think you can do it? And then they'll say yes or no. If they say no, you go find somebody else. Like, it's pretty simple. Um, but if you do it that way, then you can just do like $5 here or there, and you'll eventually accrue all of the sprites that you need for your game. Um, I would encourage you to continue using the same artist if possible, because it's going to make your game more consistent if you stay with the same artist. Oftentimes, if you jump between artists, it's going to make it a bit more complicated. But anyway, so that's like the artist. The sound designer is pretty similar. You can get multiple sound designers to make different music and sound effects or whatever until you've accrued all of the resources that you need from them. The programmer, um, you might need to be a little more consistent with, because they're going to be working from beginning to end on your project. And so it would probably be more like a part-time job kind of thing where when you find like when you get more resources for your game, then you'll notify the programmer like, "Hey, I've got more work for you." Um, and oftentimes programmers like on their weekends, like off of their other job, or if they're unemployed or whatever, you never know. um, like when they get free time, then they'll add the new additions to the game and you'll just pay them for like how many hours they worked or whatever. So you don't need to consistently pay the programmer like a full-time employee or something either, but you do need to pay them probably more than you're going to be paying the other ones, at least like more frequently. But that is like an alternative. If you don't want to be a programmer, that's a great alternative. Just be your own like project manager. And the most difficult part about it is making sure that you have a clear game design in mind and that you're maintaining communication between all members of your like quote unquote team so that you know exactly what kind of sprites you need from the graphic designer, what kind of music you need from the audio designer stuff, and then like you need to make sure that the programmer is going to accomplish the things that you want them to and that they're not going to kind of expand the scope beyond what you wanted. Um, so that's kind of one thing that I wanted to ramble about. The next thing is making a game for other people or money or things like that. If you're making a game, make it for yourself. Like 9 times out of 10, you're going to make a game, you're going to try and share it with other people, and no one is going to care. So if you're making a game, make a game that you want to play because you're going to be the only one playing it. And if that is not true, if you make a game that you like and you like playing it and someone else ends up liking it, that's fantastic. Then you can look to like sell it or something. But don't think anyone's going to be interested in it until it's done. Most people are not interested in unfinished products. And yeah, like you just need to kind of know that going in. So don't think you're going to make a game and make it big just because you made one game. Like that's just kind of the general idea I want to put out there. Um, the like third kind of ramble, which should be the last one from what I remember, is learning to be a developer in order to get a job or something. A lot of people think you're going to be a programmer. Programmers are going to earn a lot of money and you're going to be like set for life because you're going to be rolling in the dough. And like, whatever, you might hate programming, but it's worth it because of the money. I think that is a terrible way to approach programming. If you do not have the desire to be a programmer and to learn everything that there is to learn, you're not going to survive the learning process of programming. And the learning process of programming never ends. There's constantly new stuff coming out, and you're constantly going to be learning new things and old things like all together. And aside from that, just knowing how to program is not going to get you a job. Even having a degree in programming is not going to get you a job. What's going to get you a job is knowing somebody at a software company because then you'll have like an in, or having made projects that have earned you a lot of money, which like sounds kind of weird, but if you think about it, it's like, well, pretty much anyone can get a degree but not do anything with it, right? But not everyone can make Terraria and sell it, right? So if you know somebody has made a product that was desirable and sold a good handful of copies of it, then it means they probably made some good code and they're probably more desirable. And that does not mean, hey, I made a GitHub with a bunch of like HTTP server scripts or whatever that I've written, because that doesn't earn money. Nobody cares. No one's gonna look at your GitHub. Sorry to tell you. But yeah, so I just wanted to put that out there too. Like, just knowing programming is not going to get you a job, and is not going to earn you like $1 million just because you know how to program or whatever. Anyway, ramble over. We're going to go into kind of a summary of what we're going to be going over before we jump into some kind of fundamentals of different languages and things we're going to get into. So we're going to be using HTML, CSS, and JavaScript in order to make sort of our first game. And HTML is hypertext markup language. It is not a programming language, but it is a good way to make like a foundation of what a web page is going to look like before you add more things on top of it. And you will always have HTML, even if you don't add like a lot of stuff to it. It's going to be the base of your project. Then on top of HTML, you can have CSS, which is cascading style sheets. Cascading style sheets are going to change the appearance of your HTML, because HTML in general is pretty ugly. We made CSS in order to like change sizes of things, change colors of things, and just make the overall appearance of HTML look better. Now, neither of those are a programming language or a scripting language. I'm not going to get into the difference between the two. It's really kind of wishy-washy for a lot of people. But anyway, they are just like a base idea of how a web page is supposed to look. But your web page can't do anything. It can only display things with HTML and CSS. So in order to make your web page do something, you need a scripting language like JavaScript. And I want to really exaggerate here. JavaScript and Java are not the same thing. They're two completely different languages. And so if someone's talking about Java, do not talk about what we're going to go over today with them, because it's a completely different thing and it causes confusion all the time when you're looking for help with programming resources, or you're trying to have a conversation about programming with someone. Like, it's a super common misunderstanding that like basically JavaScript tried to ride on the popularity of Java, and so they changed their name to JavaScript, and it made it super complicated for everyone. um, but yeah, let's kind of look at some resources real quick. So there is a website called W3 Schools, and it says right here, learn to code, right? W3 is the World Wide Web Consortium, I think is what it stands for. But they essentially make all of the standards for all web programming languages. So if you need tutorials or anything like that, I guess tutorials cost money now. That's fine. Don't worry about that. But you see here we have HTML, CSS, and JavaScript, right? So if you click on one of these, it's going to take you to a page that looks like this. And you see like learning by examples, and it gives you an example. You can say, try it yourself. And then it'll show you the code that it's showing right here. And then it will show you the result of the code over here. And you can even change this. Like, I'll just delete this word paragraph and say run. And now paragraph disappeared over here, right? So it's super, super useful. Like I said, they write the standards for all this stuff. And if you scroll down the left side, it will tell you everything there is to know about the language. Like I said, images here, it's showing you how to add an image to your page, right? So that's cool and all. CSS, same thing, shows you a lot of different ways you can style your HTML using CSS. And then JavaScript. JavaScript is really going to be the heart of our game and what I really want you to pay the most attention to. And I would really, really like you to just go through all of these and at least try to understand what it's talking about. Like, you don't have to have the best grasp of what all of these mean. I'm going to kind of go over a lot of the basics to maybe get you like started in it so that you kind of understand how the flow of things work. But this is the language that you're going to drill yourself on the most in order to really make more complex games and things, because this is the heart of the game. Um, yeah, I didn't really make like a plan or anything for this, to be honest. So I think we'll just kind of jump into it and we'll kind of go from there. So we're on Windows 11, terrible operating system, but here we are. We're just going to make a new folder anywhere, and you can call it anything that you want. We're just making a folder to keep our like project organized, and you can name it whatever. It doesn't matter. We're going to open that folder, and there's nothing in the folder, right? We're going to right click, go to new, and say text document. And that's not like an Excel worksheet or PowerPoint or whatever, text document. That's going to make this new text document. Now, for you, if you are just on base Windows, you haven't edited whatever, it's just going to say new text document. There are two ways that we can make the file that we're trying to make, and it's not this file. One way is you can open this with Notepad, or you can just double click it, whatever opens it in Notepad, right? You can go to File, Save As, and then instead of text document, we're going to say All Files. We're going to name it whatever we want. I'm going to call it Hello. And you're going to say .html because we're making an HTML file right now. So we're going to save that now that we've changed it to all files. That's really important. And you'll see this new file was generated. So we can close this old one and we can delete this new text document, right? So now we have this. If I double click this, it's going to try to open in Chrome. And I'll just say always. And it opened this in Chrome, which is just a blank page. We haven't written anything in it, right? So that is what we're looking to do right now. Another way that you can make this file that I prefer is if you go to View, Show, File Name Extensions, then you can make your new text document and you can name it whatever you want, and it will show .txt, which is the extension of the file, which tells your computer what kind of file it is. So we're going to change that just by renaming the file. We're going to say HTML, and it's going to say, hey, if you change the file name extension, it's going to change basically how the file is going to be used. Are you sure you want to change it? Say yeah, because we want it to be used like an HTML file instead of a text file. Now I showed you, like, you can double click it the way it's set up here and it'll open in Chrome. If it's not opening in Chrome, you can right click it, say open with, and you can choose Chrome. And it doesn't have to be Chrome either. You can use Firefox, Edge, Opera, whatever browser you have installed. it will open it the same in any browser. But we don't want to just open a blank page like this, though we will want that. We want to be able to open this and edit it like it's text, even though it's an HTML file now. So you can right click it and you can say edit in Notepad is what your go-to option is if you don't want to install anything. Notepad is a fantastic way to write programs. There's nothing wrong with writing your program in Notepad. If you want a little bit of more flavor, you have some coloring to your code and stuff, you can install a program called Notepad++. This is, or at least was, my preferred program. It's the same thing as Notepad, but you're going to have line numbers, and depending on what you write, will change how like things are colored. You see this kind of went blue, and then this is like a dark blue, this is like a gray, right? So Notepad++ will color things for you, which is really convenient. I personally prefer now an editor called Zeditor. It's just, again, another text editor like Notepad. It's just a little more robust. It lets you look at files in the directory you're working in. The most used text editor for this kind of work is VS Code, which is managed by Microsoft. A lot of people trust Microsoft. I do not. But it is almost exactly the same thing as a Z editor. It's just ran by Microsoft. So, depends on your preference there. So, what are we going to do? Now that we have this hello.html, we're going to right click it and you can say edit in Notepad. I'm going to edit in Notepad++. Like I said, basically no difference here. I just have line numbers and it's colored and all that stuff. So we have this opened in Notepad. We are also going to open it in Chrome. So now we have this blank page and we have this text, and it's the same file opened with two different programs. Now we can close this because we have it both open, right? I'm going to switch these around because I like my windows laid out more like this. So in your browser, I want you to click the three dots, go to, where is it? More tools and developer tools. That's going to open this panel. For you guys, it's probably going to be, not that side. It's going to be on this side by default. You might have this like update window or something. You can just exit out of this update window. You don't need it. And then I like it being docked on the bottom of my window. So if you click the three dots and then you click the one where it's on the bottom, then now it's opened and bound to like the bottom of your browser window, right? And you can ignore this, it's fine. It's just saying you're loading a local file instead of loading like a website. And this is what we're doing to avoid like hosting it by installing a web server and all that stuff that you don't need right now. So now that we have this open, you might be on Elements or something. You're going to want to go to Console, and it'll give you this little like command line here. This is where we're going to be doing a lot of our kind of testing stuff. If we just want to run like one command and see what happens, this is where we're going to be writing it. And then in the like text editor is where we're going to be writing all of our like bulk code, like the entire game that we're going to be writing. And everything you write in the console is JavaScript, and we're going to be putting HTML, CSS, and JavaScript inside of the text file. So just a quick little test here. We're going to say console dot log. We're going to open some parentheses like this, and inside of those parentheses, we're going to put some quotations, and we're going to say hello world, like that. And you should end it with a semicolon. You don't have to anymore. I was going to say a recent update. It's not so recent anymore. Makes it so you don't need this semicolon, but I highly encourage you keep it because other languages require this semicolon. And if you get used to not writing it, it's going to cause you issues in the future. So we're just going to write it, and then we're going to hit the enter key. And you see underneath our little code we wrote, it says hello world. So console is this thing we have open right here. It says console, right? So inside of here, we want to log, or basically write, the words hello world. And so that's what we told it to do, is your console wrote the words hello world. So here it is. Super simple, super like quick way to write some JavaScript and get you in. We're going to jump away from JavaScript for a minute. So I'm going to make this a bit smaller. And we're going to have to go over a bit of website development before we can jump into making the game. There's a lot of different parts of making a video game. And the one that we're trying to mimic right now by making a web page is called a graphics framework. It's essentially what allows you to make a window on your desktop. So inside of the window, you can draw things, right? So that's a graphics framework, is giving you a little box in order for you to put your, like it allows you to put your game inside of this box or window, right? So what we're doing is we're making a website. So our browser window will act as our graphics framework and allow us to put our game inside of it. Another part that goes into making a game is called the game engine, which is kind of a broader term. It includes your graphics framework inside of it, along with all of the other code you've wrote in order to get your game to work. On top of your graphics or your game engine is going to be your game code, which is like all of the stuff that is your like storyline, it's your text that your characters are speaking, it's your audio files, your graphics, whatever. It's like everything that your game needs to be like your specific game. Like it's not going to go into any other game you make. All of that stuff is just this game. That's your like game code. The game engine is diverse enough that you could put it into a different game and like you're not going to notice that it's running the same engine or something. Like it's a bit harder to explain, but we'll get to the point where I can tell you like when we've made the engine. So we're going to start out a bit of HTML. We're going to make a less than symbol here, and we're going to say H1, and then we're going to close it with a greater than. Then we're going to do another less than, a slash, a forward slash, and an H1. What does this mean? Well, we have a tag in HTML called H1. It stands for header 1. which is a header of the size 1. And 1 is the biggest size header that we have, and it goes smaller down to 6. So if you want a smaller one, you can write the same thing, but replace the 1 with like a 6 or a 2 or a 3 or whatever. And we're just going to say hello world inside of here and hello world inside of here. And we're going to save the file. Remember to save the file anytime you make a modification to the code, because if you don't save the file, it's not going to show up on your web page. Now, on your web page, you need to refresh the browser's page in order to see the changes. You can do that by clicking this little refresh button, or you can do Control R, which will also refresh your page. And you see, we have this big text saying hello world, and then we have this smaller text that says hello world. The bigger one is our H1, the smaller one is our H6. And that is the general layout of how HTML is going to work. Is you have a starting tag, and then you have a closing tag. And the difference is the starting one is just the tag name, and the closing one is a slash and then the tag name. And we can break these into different lines and we can indent them. We can do like a bunch of weird spacing stuff. We can go like this, and that is still going to show exactly the same. Um, and this will allow us to do something called nesting later. Um, that is useful for like organizational purposes. So we're going to delete this stuff. Now that we've gone over headers, we also have P and /P. This is a paragraph. So if we save, refresh the browser, it says hello world and it's not bold and it's like a decent maybe 12-point font size, something like that. That's a paragraph, and we use P to denote paragraph, right? There are tons of HTML tags. If we look here, you see there's all these things. We have, let's see, paragraphs. We have tables, lists, we have different ways to display HTML stuff. We have divs, classes, IDs, buttons, iframes. There's tons of different HTML tags that you can get into. We're going to kind of forego a lot of HTML. We don't really need it in order to get started making a game, other than to make what is called a canvas. And I'm going to add some attributes to it. I'm going to say the width is 600 and the height is, I did this backwards. I want it to be 800 width and 600 height. And I'm going to save that and refresh, and you're not going to see anything. The reason you don't see anything is because the canvas is white or transparent, depending on what how you want to look at it. But if I right click and I say inspect, and I look at this, and I hover over this, you see on my page, there's this highlighted blue area. That's where this canvas is. And the canvas is 800 pixels in width and 600 pixels in height. We just can't see it because it's white or transparent. So we're going to change it a little bit, bring this back to console. We're going to say border equals 1. I believe that will help. It did not, which is great. I'm a little bit not used to web development anymore. So we're going to do style equals, and we're going to say border 1px solid black. This is not necessary, the style border 1 pixel black, in order to get the game to work. This is some CSS that we're putting in, and when we refresh, now you'll see 1 pixel, which is this 1px, of a solid black line that is the border. And the reason I'm doing that is because I need you to see where the canvas is. If this is visually going to make any sense to you guys, right? So we have this canvas now, that's great, but we can't do anything with the canvas. Um, like we can't put any images in it. We can't, change the color or whatever unless we add more to our code, right? So I'm gonna show a little bit of CSS, and that's to give you kind of a taste of what CSS does. So we're gonna make a new tag called style. You can see it's a lot like style here because style means CSS. We're changing how this thing looks. We're going to make some new lines and we're going to close that style tag. So it opens here and closes here, right? Inside of that, we're going to say canvas and we're going to open it with a curly brace. We're going to go down and we're going to close it with a curly brace. What does this mean? Inside of style is CSS. CSS has a special way of basically targeting things in your HTML. So let's see if we can find a good example. It's interesting that they're doing this all in line. So like I was saying, you can put style or CSS inside of your HTML like this, or you can do what I'm trying to show you, and you can say like canvas, which means anything on your page that is a canvas, you want to do these rules to. And inside, you can just say like border colon 1 pixel solid black and end it with a semicolon. You can see, other than canvas and these braces, this is exactly the same thing that we wrote here. We have style, which is style. We have border, border, 1 pixel solid black, 1 pixel solid black. So it's exactly the same thing. It's going to do exactly the same thing, but I can delete it out of here, which is going to save space in our like editor looking at it. Essentially, it's to clean up your code and make it easier to know what's going on. We can additionally add more things to the canvas here. Like if I say background, I say blue, and I save it, and we go back and refresh, now you see the whole canvas is blue because we made the background of it blue. And it still has that 1 pixel border, it's just harder to see because of the coloring. So we can add more and more things to this, and it's not going to get super messy because it's crowding up all of our HTML stuff. The reason that you want to separate it like this in this like style tag instead of writing it all in here is because it breaks up your code into sections. This is your CSS section. this is your HTML section. And then below our HTML section is going to be our JavaScript section. So if you're looking to change something in CSS, you know where to look. If you're looking to change something in HTML, you know where to look. Same with JavaScript. So we can even take these out because this is the HTML way of denoting width and height. We also have a width and height in CSS. Actually, I lied. Because of the way the canvas works, we have to do it in HTML. So yeah, we'll leave it like that for now. One thing we will need to add is an ID, and we're gonna put that in quotes, and we're just gonna say canvas ID. Okay? An ID is a way of giving this specific canvas a name. So if we are looking for this specific canvas, we have a way that we can call on it. Because I can have more canvases on my page, right? Like I can just do this and have like 20 canvases. And then if I just say canvas, then there's no way to differentiate between them. So it's going to make a bunch more canvases, right? And the reason they're a different size is because we didn't tell them what size to be. So this is just the default size of a canvas. So in order to change CSS to only be the ID canvas ID, you're going to change this canvas to be a pound sign, hashtag, hash mark, whatever you want to call it. And then you're going to write the name of the ID, canvas ID. Now, when you save it and you refresh, you see none of the other canvases have a border or are blue. They're still there, you just can't see them because this is the only canvas that we're applying the border and background to. So we can get rid of these now. We only need one canvas for our purposes. Now, I'm going to add two more things just because I prefer being really straight with it. This displays it as a block level element instead of like an inline element or something like that. That's a more complicated thing with CSS and HTML we're not going to go into, but feel free to Google about that. W3 will absolutely tell you all about that. And then margin zero auto is a shorthand for saying zero auto, zero auto. Basically, it's saying I don't want to move it down the page any, but I want it to automatically move it from the left. I don't want to move it up any, but I want to automatically move it from the right, which essentially ends up with it just being centered horizontally. And again, this bit is unnecessary. Even the background is unnecessary, but I'm doing it to visually, make this more appealing. Okay, so we did some really, really basic CSS, and we've made like one or two HTML things, and now we have this canvas, right? I'm going to delete the background, but keep the border. So now you see everything inside of this border is our canvas, and everything outside of it is not part of our game. Okay, I just want to like make that very straightforward. And we're going to make a game with a bit of graphics. It's going to have a refresh rate of like 60 frames per second, something like that. And we're going to accept some controls and move a character around. We're not going to get into graphics or audio. Those things are a bit more complicated, and I've made streams that explain how to do those things. So if you look at the channel, there'll be, I'm pretty sure, a playlist for like web development game. Um, and you should be able to tell by the title what I'm teaching in that stream. And so you can just kind of skip around until you find what you're looking for. But this is just kind of a basic get you in, get you started, see what you can make kind of tutorial. So we have our CSS, we have this tiny bit of HTML. We're going to make a script HTML tag. Everything inside of script is going to be JavaScript. So if we say like console log hello world, we wrote that before over here, right? If I just copy and paste this into the console and hit enter, it says hello world, right? I'm going to clear this just so you don't think it's the same thing as before. We're going to save the page and we're going to refresh this. And you just see hello world here. But we didn't tell it to print hello world in the console. We told it to do it here in our code. This code is going to automatically run when you first load your page. So anytime you refresh your browser page, it's going to spit out hello world to your console. If you don't have your console open and you refresh, you're never going to see this. And if you open your console after you've refreshed the page, a lot of times you're not going to see this. So make sure your console is open when you refresh your page in order to make sure that everything is working properly. Okay, so we have logged out to the console. That's fantastic. We're going to dive into a like fundamentals of JavaScript section now, where I'm going to teach you how to make variables, different kinds of variables you can make, and sort of different things that you can do with them. And that'll get you kind of started knowing how JavaScript works and kind of the limits of it possibly. So we're going to leave this console log for a minute, and we're going to go above it or below it. We're going to go above it. So we have variables. Variables are like boxes that you can put things in. And you can put words, you can put numbers, you can put sounds, images, you can put anything inside of these boxes, but you can only put one thing in the box. So, like one image, one number, one phrase, or something like that, right? And there's a couple different ways to make variables. We have a word called var. We have a word called let. It's trying to help me write something. We have let, and we have const. This is variable. That's just let. And const is short for constant. What you're going to do after you say var, let, or const is you're going to make a name for your variable, or you're going to name the box that you're making. So I'm going to say like my name. This is a pretty conventional way of naming your variables, is you start with a lowercase for your first word, and every word that comes after your first word is going to start with a capital letter. So I could say like my name is Floaty Boat. There cannot be a space in your variable names. If you want to do a space, we usually do an underscore instead, because that keeps it all as one consistent string of characters, but also visually gives you the idea that there would be like a space there, right? So like Python has a different naming convention. They could be like, my name is Floaty Boat. Could be the name of one of their variables. It really is preference when it comes down to it, because it doesn't make a difference as far as functionality goes, but this is just kind of the convention that we've come up with. So you're going to say var let or const, the name that you want your variable to be, equals, and then what you want to put inside of that variable. So I can say like 22, and then semicolon. You should end pretty much every line that you write with a semicolon. There are exceptions. We'll go over them. But anytime you're telling the computer to do something, you should end it with a semicolon. Now, what does this do? This takes the number 22 and it puts it inside of my name, which is the variable that we've created. So I'm going to do what's called a comment. I'm going to do 2 slashes for both of these, and I'll explain comments in a second. Now, if we just refresh our page after saving, nothing changes. Where is this 22 and my name? Like, I still see hello world, but I don't see this, right? This is stored behind the scenes in your computer's memory. So we haven't told it to do anything visually with this yet. We're just telling it, hey, there's a number 22. We want to put it in this my name box. And if I need it later, then I want to be able to pull it out of that box later. But we haven't pulled it out of the box yet. So what's one way that we can pull it out of the box? Well, if we go to our log here, our console log, where we're logging hello world, we can delete the quotes and everything inside of the quotes and just type my name, which is the name of the variable we created. No quotes. If you have the quotes, it's just going to say my name. It's not going to say 22. If we refresh after saving, now we see 22. Well, that's weird because I told it to say my name, right? But what it's doing is it's saying my name is a variable because we didn't put it in quotes. So we're going to go look for something called my name. And it goes up and says, oh, this is my name. It's a variable that we made, which means that it's a box we put something in. And what's inside of it? 22. So it automatically unpacks that box and grabs whatever's inside of it. And then it replaces this with whatever it found. So this is the same thing as me typing console log 22. And if I refresh, you'll see 22 twice because we're logging it once here and we're logging it once here. Exactly the same thing. The only difference is that it had to fetch 22 from this variable we made instead of just putting 22 out. Okay. Comments real quick before I forget. You can put a comment anywhere in your code. You just do 2 forward slashes. You can say like, hello, my name is Boat, right? And if I refresh, it doesn't change anything. Anything in front of the double slashes is a comment, which means it's not supposed to run. It's just some text that you wanted in your code for some reason. This can be useful for organizing your code into sections, leaving little comments to yourself about what the following code does, things like that. And then if you ever want to do multiple lines, like if I just had comment after comment after comment after comment after comment, and like this entire thing is just one big long string of words that I want to be a comment, instead of doing all of these slashes, you can do slash asterisk, and you're going to end it by saying asterisk slash. Now you'll see end is not green like this comment is right here, right? But I want this to be part of the comment. Well, this star slash is the end of this comment. So this end is not inside of this comment, it's after the comment. So you can do like this, and now end is inside of the comment. Or you can break this to the next line, and now it's inside. And you don't have to put the text right after. You can go like that. Like it's very similar to the HTML tags, as long as you're doing this multi-line comment. So I might do that sometimes to kind of show like what we're doing, but most of the time I don't. Now to get back to the difference between var, let, and const. The difference between var and let is scope. Var is global scope, and let is block level scope. Right now, don't worry about that. Like, it's a more advanced topic that you'll run into eventually. It's not going to cause any issues. Most people don't even worry about var. They like never use var anymore. So for the most part, we're going to be using let. So instead of var here, let's just say let and delete this, comment that out. If we refresh, you see it does exactly the same thing. Because like I said, var and let are the same thing. Difference is scope. Scope doesn't matter to you right now. But we're making a variable. We're putting 22 inside of that variable, and then we're fetching that variable later. Now, const is a constant, which means it's unchanging. The thing that's fun about var and let is that kind of signifies that you're going to be changing what's inside of this box in the future. And to change it, you could say like my name equals 55. And you'll see I didn't say let or var when I'm changing the value. You only say let or var when you're initially setting the value. So my name is 55 at this point in the code, but it was originally 22. If I save, I'm just going to delete this one because we don't need it twice. I need to comment this out too. So if we save, refresh, you see 55. Well, where's our 22? Our 22 was deleted. We opened my name here and we found 22 and we ripped it out of that box and we put 55 in instead. And then we resealed the box and tucked it away. Where'd the 22 go? It vanished. We've completely deleted it. It's not in your memory anymore. We've overwritten it. So then when we go to fetch the value of my name down here, it says, well, go fetch the box for my name. And when we open it, we find 55 because we've thrown 22 out and we found 55 after we replaced 22 with 55. So that's how you can update a value of a variable. Const is just our way of writing that we're never going to do this to the variable. We want to say, my name is 22. And this way of writing it does exactly the same thing as this way of writing it. It's just acknowledging to you and anyone else reading your code that you should not change what is inside of the my name box. For whatever reason, it's critical that this box keeps the number 22 in it. So anytime we go to fetch it, it's going to find 22. And there's a number of cases why you might do this. A lot of people still just use let for everything, because even if you use let, you don't have to change what's inside of my name. You can just leave it as 22 and it's not going to cause any issues anywhere in the future. So primarily, just use let for everything. Like that's just going to be my go-to for you guys. Just use let for everything. Um, Now we know how to make a variable. Let's talk about some different kinds of variables. One second. Okay, so let's talk about some different kinds of variables. We have numbers. As you can see, we have like 22. We can have 22.05. We can do decimals. Isn't that nice? We cannot do fractions. If you're going to do a fraction, you need to write it as a decimal instead. And you can do like super big numbers. There's not really a limit on it in JavaScript. Other languages, there is sometimes, but this is fine. And then you can do like 0.999999999, whatever. You can do any number here. Do not do commas. We don't like delineate numbers by commas in programming. So if you have like 1,000, do not put the comma here. That will break your code. Just leave it straight as the number. So that's numbers. You already saw that. We have what's called strings. What is a string? A string is a string of letters. So you write a string by putting quotes, and then anything you put inside of the quotes is a string. And we saw that when we wrote hello world. So this is a string. We have a bunch of letters or characters, whatever you want to call them, that come one after another, and we want to box them all as written inside of this box. So again, we're going to save it, refresh, and we see hello world. Because we looked for the box, we found the box. Inside the box was the text hello world. If we don't put it in quotes, then the script doesn't understand that all of this text belongs together, and it's going to cause an issue. So if I refresh now, it says there's an error. It found world, but it doesn't know what to do with world because it's not grouped with hello. So that's why we do the quotes. You can also do single quotes. That will also work. Or you can do the like single quote that is above your tab key. That is called a grave, like what you would put a body in. That also will work. So if you ever need to do like quotes inside of a string, but you can't put quotes inside of quotes, like I can't do a string like this and then have quotes inside of the quotes. You just can't do that. Like technically you can by escaping them with backslashes, but we're not going to get into that. Um, so if you have like one type of quote that's surrounding it, then you can do a different kind of quote inside of it. And I'll kind of show that. So we have these quotes here because I used grave to surround it. Most of the time, you'll just be doing double quotes. um, and it'll be like that. Okay, so that's strings. We have booleans. booleans, which is written like that. And we can set a variable to a boolean. What is a boolean? Well, the value of a boolean is either true or false. So when someone talks about a boolean, they're saying it's either true or false, is what they're really saying. And we can say our variable is true, or we can say our variable is false. And a lot of things a boolean is not going to be very useful for, but there are very particular circumstances that a boolean will make your code a lot more readable and uh, I don't know. There's like particular cases where I would argue using a boolean would probably be better, but for the most part, it's not entirely necessary. Um, so what happens when we log this? It just says false because it's just finding that value and then printing out false. Or we can say true, save, refresh, and now it says true. Now, this kind of leads us into what's called conditionals. A conditional, as you've probably heard from some programming knowledge you have, is we have this word if, and then we usually have like then after. So if dot 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 happens, then do blah blah blah, right? The way that we write this in JavaScript is we say if, we do some parentheses, we do a brace, like a curly brace, we go to the down couple lines, and we end the curly brace. So we say if something happens, then we want to do anything in between these curly braces. Now, what do we want to check if it happens? Well, anything that is in here, if it's equal to true, then we're going to run the code. If it's equal to false, then we're not going to run the code. So let's take this log, we'll put it inside of the braces, right? And we're just going to say my name in here. If my name console.log doesn't make a lot of sense, right? But let's just see what it does. So we're going to refresh, and it says true. Let's change this a little bit. Instead of saying true, we're going to say ran if conditional, something like that. And we'll refresh, and it says ran if conditional. That means this code between the braces ran. Why did it run? Because my name is equal to true. So if true, then do this, which as I explained, if true, then we're going to do what's between the braces, right? If I say this is false, and I save and I refresh the page, we don't say ran if conditional anymore, because now this is if false, then do this. But like I said, if false, then we're not going to do what's between these braces. Now let's change it back to true. So it will run the conditional. We have an additional thing we can add to this if statement called else. And we're going to open a brace and close a brace. This part doesn't have a check on it because it's going to do the opposite of whatever's in here. So if this is true, then we're going to do this, right? But that means that if it's false, if it's not true, then we're going to do whatever's between these braces. So let's copy this. And we're going to say Didn't run if conditional. Okay, we'll save, refresh. We say ran if conditional. We don't say didn't run if conditional because it's true, it's not false. If we change this to false, then this is going to be false. So it's going to skip this, but then it'll run this code. So we refresh now, and it says didn't run if conditional, which is this code that we wrote here, right? So if this, then do this. If that did not happen, then do this instead. So that's if conditionals. We also have else if, which allows you to add another conditional thing here. We don't use else if very often. I would not worry about it for now. Just kind of keep going with if and sometimes else. You don't always need this else. But yeah, that's the basics of conditionals. We also have something called a switch that is really nice if you want to look that up and figure out how that works. But we're not going to go over that right now. So that is a if statement conditional. Now, let's go over a different kind of variable that we can make. We have numbers, strings, booleans. Now I'm going to show you how to make an array, which is spelt like that. All you need is a square bracket and a square bracket, and they're going to point towards each other like they're making a box. This is an array. Inside of this, you can put multiple values. And you might think, but Floaty Boat, you said you can only store one thing inside of this box. That is technically true because we're making one group of things and we're putting this one group inside of this variable. I know it's kind of iffy. Like, it makes sense, but it's kind of like, all right, bro, you're kind of stretching it, right? So inside of these square brackets, we can say like 22. We'll do a comma. A comma is how we're going to separate the things inside of this array. An array is just a list of things. I don't know if I really said that or not, but that's essentially what it is. It's a collection of values. We can say 22, 66. Let's do a string inside here. We'll say like hello world, and then we'll say like false. In JavaScript, you can put all different kinds of types of variables in here. You can make it as long as you want. You can write it on separate lines like this. You can get really flexible with JavaScript as long as you're still following the rules on stuff. So, why is this useful? Well, like we were saying earlier, you can only store one thing inside of a variable. But what if I want to use the same variable for multiple values? Well, this is how you do it. You make an array because then it can have multiple values. And you're going to need to be able to access these variables or these values inside of here more than just saying console log my name. If you do this, it will work. The problem is you're grabbing the entire set of values. You're not grabbing one value, right? So you'll see 22, 66, hello world, false. We grabbed this whole thing, the whole collection of values instead of just one, which let's say I want like 22 out of this, right? Well, you might say, this is the first value inside of this collection, right? So maybe I want like my name one or something because it's the first position, right? Well, that's almost what we're looking to do. we're going to do square brackets around this 1, and we're going to save it and run it and see what happens. Now we see 66, which that's weird, right? Because we wanted the first one in here, which should be 22, but we're getting 66, which is the second one. Like, that's really strange, isn't it? That's because the way that arrays are indexed, they start at 0. So this right here is 0. This is 1. This is 2. And this is 3. So there are 4 things inside of here, but the indexes go from 0 to 3. So I'm going to just comment this so we can keep it here. If I say 0 and refresh, now I'm getting 22 because, like I said, the first one's index is 0. Now we already saw 1 is 66. Let's try 2, refresh. We're getting hello world. So we're being consistent about it. This is the second index, which is what we're looking for, and that's hello world. So that's just a key little thing you're going to have to remember about these collections we call arrays is whatever position you're looking for is actually one number less than the one you're looking for. And that can get really confusing and annoying sometimes, and you're going to have to get used to it, unfortunately. But pretty much everything in computer, like collection and stuff, or memory management or whatever, is 0 indexed, which means it starts at 0 and then it counts up from there. So if you run into that again somewhere else, just know like that's the normal way we do it here. Okay, so this is cool and all. Let's just punch them all out here. So we'll have 0, 1, 2, and 3, right? And then we'll refresh and we see 22, 66, hello world, and false. So we managed to get through everything in here, right? That's really cool. I don't want to keep writing this over and over and over again when I keep adding more values, right? Like if I do this, this, that, Bob, something like that. I don't want to have to be like, okay, console.log, console.log, console.log. I don't want to keep doing this. That's super repetitive. It doesn't look very nice, right? I want to just start at the beginning, go all the way to the end, and do the same thing as this, right? Well, there's a thing we call loops. And loops are how we're going to do this repeatedly, but do it a little bit different every time we do it. So let's look into loops. Let's make a variable real quick. We're going to call it count, and we're going to set it to 0, okay? And we can do math inside of JavaScript. So if I said like count equals like 5 plus 2, then that's going to rip this 0 out and it's going to replace it with whatever 5 plus 2 is, which is 7. So now count is going to be equal to 7, right? We can also say I want count to be count plus 2. Whoa, that's weird, right? What that means is we're going to go get the value of count before this line. We're going to take it out of the box. We're going to add 2 to it, and then we're going to put it back in the box. So this is going to be 0 plus 2, which is going to be 2, and we're going to put that inside of count. So from now on, it'll be 2. and we can do addition, subtraction, multiplication, division, and like that's just how you would do arithmetic and stuff inside of JavaScript. But we're going to use this count equals count plus whatever. We're going to say 1 in order to make a loop. So we're going to just comment that out for now. Go down a couple lines. We're going to say while. While is the first kind of loop we're going to go over, and then we're going to go over the for loop. But while is where we're starting. So while, very similar to the if conditional, is going to have some parentheses here and then some braces. And inside the braces, big surprise, is going to be the code that runs as long as something is true. So whatever is in here, if it's true, we're going to do whatever's in here. And for now, we're going to say console.log. And instead of this, we're going to say count. Okay. And then we're going to say while count less than 10. Okay. I didn't show you this about if conditionals, but you can also do less than, greater than, less than or equal to, greater than or equal to, or you can check if something is equal to something, which is 2 or 3 equal signs. I suggest just doing 2 to begin with, because 3 means that it's type explicit instead of type implicit, which is a more complicated topic we don't need to worry about. Just know that if you're comparing two things, it's 2 equal signs. If you're setting it, it's 1 equal sign. So here we're saying if, basically, count is 10, if that's true, then we're going to do whatever's in here. But we're going to modify this a bit. We're going to say if it's greater than 10, then we're going to, or no, let's do it if it's less than 10. How about that? So if it's less than 10, we're going to do whatever's in here. And we're just going to write whatever count currently is. Now, I'm going to save this. We're going to run this. It's probably going to crash the page. So before you like quickly do what I'm doing, maybe give it a minute. So I'm going to refresh. And we just see it's spitting out the number 0 like 2,000 times a second, right? And we can see because this number keeps going up, it's just printing the same thing over and over and over and over and over and over and over again. And that's not what we wanted. So we're going to comment this out real quick and save it and refresh the page again. We're actually going to have to close the page possibly. Wow, it was freaking out. That is called an infinite loop. We don't like those. An infinite loop can basically freeze your browser. It can like stop your code from running, all these things. Like we do not want to make infinite loops, which is what this while is, because it says while count is less than 10, right? Well, what's count right now? Count is 0. 0 is less than 10. So we're going to do this. And then we're going to go back and we're going to say while count is less than 10. Then we're going to do this. Well, we haven't changed count. Count is still 0, right? So that's still true. So we're going to do this again. And we're going to do it again and again and again infinitely, because we are never changing the value of count. It's always going to be less than 10. So we need to fix that. We need to say count equals, And then I could just say like 11, right? Because 11 is bigger than 10, so it'll no longer be less than 10, right? So if I save it and refresh it, now we see 0 and 22. And that stray 22 is coming from here. We're just going to delete that. So we see 0. What's happening is we're setting count to 0. We're getting to here and we're saying while count is less than 10. Well, 0 is less than 10. So we're going to log 0 because that's what count is right now. And then we're going to rip 0 out of the count box. We're going to put 11 inside, and then we're going to go back to the top. Well, now count is 11. 11 is greater than 10, not less than. So then we're not going to run what's in here, right? So we never print it out again. We're just going to exit and continue with our code. So that's super cool. What if I want it to run more than one time though? Because what's the point in having a loop if it only runs the code one time? Well, you can say count is count plus 1. What's that going to do? Well, we're going to have 0. We're going to come down here. It's going to be true. It's going to log 0. And then it's going to say take our count, which is 0, add 1 to it, and put it back in count. So now it's 1. And we're going to come up here and it's going to say, is 1 less than 10? Yes. So then we're going to log 1. And then we're going to say, well, what's count now? It's 1. Okay, add 1 to that, which is 2. And we're going to put that in the box of count. And then we're going to go up again. Is 2 less than 10? It's going to keep adding 1 every time we go around until we're greater than or equal to 10. So now when we save it and run it, whoa, it spat out a bunch of numbers, right? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Cool. So we've run this thing 10 times and we got the numbers 0 to 9. Like I said, every time it added 1 and then it printed it out. And you can be like, well, what if I want to include 10? Okay, equals 10 instead, or like it's less than or equals to 10. Now we have 0 to 10. That's technically 11 values. What if I wanted to start at 1? Well, you can either set this equal to 1 because you're changing the starting point, and that'll give you 1 to 10. Or you can move the increment or the addition of 1 before you write the number, and then that'll make it start at 1, but then it's ending at 11 because we added this equal sign. So let's remove the equal sign, save it, refresh. Now we just have 1 to 10, right? So the order that you log it and increment it matters, and where you start matters. Like basically it all matters. You're gonna have to kind of do a bit of math to make sure that this all works out the way that you want it to, right? And you have to make sure that eventually you're going to get out of this loop. Because if you don't, your program's gonna crash basically and freeze your browser. Which, as you saw, is not a crazy problem. Like, you just close the page, fix your code, open the page again. Not a big deal, but it's really frustrating when you're just trying to get your game to work and then it freezes up and you like throw a fit because you're a bad programmer. And like that's fine, it happens. Um, and that's something you're going to run into a lot is you're going to make tons and tons of errors being a programmer. Don't beat yourself up about it. Everybody makes the problems. Even veteran programmers make errors or like infinite loops all the time. It's not a big deal. Just go back, look at your code again, try and figure out what's wrong with it, fix it. If you can't fix it now, give it a break. Take a walk, go do something else, maybe even go to bed for the day, whatever. Like you don't have to fix it right now. Come back with fresh eyes and you'll figure it out. Um, but yeah, that's a while loop and kind of how that works. Like you start at a number, you keep incrementing it essentially, or you can decrement it to, you can say minus, as long as it's greater than 10, and we can start at like 15 or something, and this will go the opposite direction. We'll start at 15, we'll go down uh, until we reach the number, right? So we start at 15, go down to 11, and then 10 is not greater than 10. It's equal to 10. So we're not going to do the 10th one. Okay, now the like important part of this is we said you can start at 0 while 0 is less than, let's count how many of these there are. There's 1, 2, 3, 4, 5, 6, 7. There's 8 of them, right? What if I change this to 8? And we're going to change this back to plus. What if I say I want to log my name, and then in square brackets, I say count? That looks kind of weird, doesn't it? It's going to take count, and it's going to look for the count position inside of my name, and then it's going to write that. And what that means is like if count is 0, then we're looking at the 0th position of my name, which is going to be 0th 22, right? And then it's going to log that. But then we're adding 1 like we did previously, so now it's going to be 1 instead of 0. So the next time we come around, this is still going to be true, and then it's going to say find the first position of my name, which is going to be 66, right? So if we save this and we run it, isn't that pretty cool? We get 2266 hello world, 2266 hello world, all the way to Bob, right? So we just did all of our values from this variable by writing one log because we put it inside of a loop. So then if I say, well, I want to add more, like I said, we can move this to another line, and we can like break this up a bit so that we have more room, comma, uh, Steven, 77, and false. You know, we added some more values. We added 3 more. So let's add 3 to this. 8, 9, 10, 11, right? So now there's 11 things inside of this collection. Boom. We just printed all of, or logged, I should say. If I ever say print, I mean log. They're essentially the same thing. But now we see even the 3 new ones that we added, and all I had to do was change the number that's right here in order to go through all of them. That's really cool, right? But there's an even slimmer way that we can do this same thing, and it's called a for loop. For loops look really scary. They're really not. We're going to get into it. Let's delete count here. Let's kind of fix this up a bit. So we can go back to just like this list that was pretty easily visible. Okay, let's even get rid of Bob. Okay. So we did this while loop. That was really useful, really cool, and you can do tons of things with loops. You could even start this at the end, and you could subtract 1 all the way down until 0, and you'd go backwards through it. So then it would write the list backwards. So if you ever wanted to reverse the order of this, you could use a loop to do that, which is really cool. Um, but we're going to do the same thing we just did, but using a different kind of loop called a for loop. And like the while or the if conditional, we have a condition that needs to be true in order for this to run. And then we're going to do some braces. Now, this is where it gets a little bit scary, but we're going to break it down because it's really not that different from the while loop. We're going to say in here, we're going to say count equals 0. Okay, well, we did that for the while loop, right? We just didn't put it inside of the while loop. We put it up here. Okay, so let's move on. Count is less than, what was this? 1, 2, 3, 4, 5, 6. 6. Okay, so this is kind of a weird way that we're writing it, but we haven't really written anything new. Like we made count, which is equal to 0. And then here is like in the while loop where we were saying if it's less than 7, right? But here we're saying 6 because I deleted an extra one by accident. Um, so like that's not a big deal. It's still very similar to what we were writing before. Now we're going to say count equals count plus 1. Well, hey, that's the part that we had inside of the while loop that made it so it wasn't an infinite loop anymore, right? So really, we just wrote the same loop we were doing for the while loop. We just wrote it all in one row, right? Like all on the same line. And that's the purpose of the for loop, is to write a while loop in a more concise way. So you can do everything that a for loop does inside of a while loop. And similarly, you can do everything in a for loop that a while loop does. It's just a different way of writing it, and most people prefer this for loop way because it's easier to know that you're going to escape from a for loop. Because without this part, your for loop won't run. If you wrote your while loop and you forgot this bit, then you just made an infinite loop. So this is just a different way of writing it. I'm going to show you a quick little shortcut. We've been saying count equals count plus 1, right? There's another way to write this, which is just count plus plus. This means exactly the same thing as this. It's just an easier way to write it. Anytime that you want to go up by 1, you just do plus plus. Anytime you want to go down by 1, minus minus. Big surprise, right? Well, you can even do this for like plus 5. The shortcut for that is count plus equals 5, which means we're going to add to what it already was 5. Now, this is a little less common than these two, but I like using this as well. I don't like rewriting the variable name very often, but this is like just different ways that you can write these like arithmetic changes to your variables. So we're gonna go here and we see count equals count plus 1. Well, we said that's the same thing as saying count plus plus, right? So I'm just going to replace that. That's exactly the same thing that I had written before, just written in a more concise way. So now inside the braces, we can run some code. We're going to say console log hello world, right? Refresh. We get hello world 6 times. Why is it 6 times? Because we start at 0. Every time we go through the loop, we're going to add 1 after the loop finishes, which is going to mean counts 1. So then we're going to check, is it less than 6? 1 is less than 6. So we're going to run it again, and then we're going to increment it again. It's the same thing as the while loop. But then here, I'm just saying hello world. So it's just doing it 6 times. You can also still say like count. If you run that, now you see 0 to 5, because 0 to 5 are the values that we'll have as long as count is less than 6, and then it'll exit. We can also do my name count. You remember that from the for loop. We refresh this. Now we've gone almost through the entire thing. I think I might have 1, 2, 3, 4, 5, 6. Yeah, there's 7 values. So this needs to be a 7 if we want to go through all of it. Now, this is super annoying though. Every time we add something to this, we're going to have to increase this number. Anytime we remove anything from this, we're going to have to decrease this number, right? Super annoying. There's an easy shortcut that you can use to get the size of this array. It's my name dot length. And this will count how many things are inside of here for you, and it'll say the number instead of this. So we're just going to cut this out, and instead of 7, which is how many of these we've counted, we're just going to say my name dot length. What's that going to do? The same thing. Does exactly the same thing. But now I'm going to say, well, I don't want 5, 8, or true anymore. So I'm just going to delete those, save it. When I refresh, it works still. I didn't have to change this code at all because this adapted to the change that I made. So that is a really nice way if you just want to loop through an array, hit everything inside of it, run some code about it, and you don't want to have to update this anytime you change this. That's a super nice, concise way that you can do a loop through an array. Super useful, super useful. We're gonna move on. You can also do similarly to our other way. We can do like minus minus, say if it's less than or if it's greater than, and then start at like 7 or something. And then we'll do this has to be -1 and 0 equals, and I reversed it. So same thing as the while loop, is we can do it backwards and we'll just go through the values backwards. Okay. We've covered for loop. We've covered while loop. That's all the loops that you need to know for now. We're going to go over functions. Functions are really nice, and we're going to work with a for loop in a second. You can also arbitrarily put numbers in here. You don't have to loop through an array. So I can say like count equals 0. Well, count is less than 10, count plus plus. And like we saw, I can just say like count and get just 10 numbers, right? Because we're running this 10 times. But we don't have to use count at all. We saw that with like hello world. We can just do hello world and it'll write hello world 10 times, right? So we're going to use this in a second. I'm just going to comment this out. We're going to say function. Functions are really cool. Functions are blocks of code that you intend on doing multiple times. Now that sounds like you're just wanting a loop, right? Because if you want to do it multiple times, why don't you just make a loop and then put it inside the loop? Well, we don't necessarily want to like do this 10 times in a row. We want to like do a bunch of things and then do something else and then do the bunch of things again. So there's like a little break between the times that we do this multiple times, right? And we don't want to write all this code over and over and over again. So we're just going to say like log hello here. And we're going to do some parentheses and some braces. These parentheses are not a like comparison, like an if conditional or a loop or anything like that. These are for what's called parameters, and we'll get into that in a second. Right now, we don't have any parameters, so we're just going to leave it empty. But we're saying function because we're declaring a new function, and then we're saying log hello is the name of this function. Anytime we want to run the code in here, we're going to say log hello. And then inside the braces is where you're going to write your code, right? So I'm going to say console log hello world. Okay, I'm going to refresh the page. Nothing happens. Well, why not? We've made this function and it has some code that says log hello world. This function is not going to automatically run. We have to specifically tell this function that we want it to run. In order to do that, we're going to say log hello, which is the name of this function, and then we're going to do the empty parentheses and a semicolon. This is called calling the function. You're writing the name of the function and you're writing the list of parameters that you need. Like I said, we don't have any parameters. So right now this is empty. We're going to change that in a minute. But now we're actually saying, I want you to run the code that's inside of this function. So when we refresh, now it says hello world because that's what's inside this function and we called the function, right? We can also just paste it a bunch of times, right? Refresh. Now it's done hello world 4 times because we called the function 4 times. You know, it's kind of similar like we're saying about the log, how you were pasting it several times. Well, what if I just like make a loop and I just say like log hello, and then we can delete these, right? You can do that. It wrote hello world 10 times. It's just the console is truncating it to make it easier to look at because we wrote the same thing 10 times. um, so you can do that. You can call a function inside of a loop. And then let's say console log floaty boat. Okay. And then let's do another loop with log hello. And we'll refresh. What you'll see is we did hello world 10 times. And then we said floaty boat because we did that here. And then we did hello world again 10 times. This is kind of what I mean by like we can do it multiple times and then we can take a break and then do it multiple times again. But let's say I had like a bunch of different console logs here. My name, something like that. And we'll say like is floaty boat. I am really cool, right? So now we have all of this text inside of our loop. If I wanted to do this loop again after I write this floaty boat, then I'm gonna have to copy all this and I'm gonna have to paste it down here again, which gets really big and bloated and like can cause a lot of confusion eventually. If I refresh the page, it still does what we wanted it to. It'll say, my name is Floaty Boat, I am really cool 10 times. And then it'll just say Floaty Boat in a more like stylized way. And then it'll say, my name is Floaty Boat, I am really cool again 10 times. But this is like really messy and it's adding a lot of code to our page. So what we can do instead is let's take this code, we're gonna cut it, and we're gonna put it inside of this function called log hello, right? And then we can just delete this. And what if we just say log hello now? Instead of writing all this stuff in here and here, we can just say log hello. That's a lot more concise, a lot more clean. We packed it all away into this little function box we call log hello, right? We refresh, does exactly the same thing. It does all of this 10 times, says floaty boat, and then does all of this 10 times again. So that's the power of a function, is you can kind of take a big block of code you plan on using multiple times, and you can just kind of like tuck it away. You're like, I want to do all this stuff later, and probably more than once. So that's the point of a function. Now we're going to get into parameters of a function. So I said that these parentheses are for a list of parameters. Well, what if I say name and age? So I'm making like a list of things that could be variable names. Okay. It's like name, it could be a variable, age could be a variable, but I'm not doing anything with them yet, right? If I say log hello, I believe this will still just say my name. Yeah, JavaScript is pretty flexible. It's gonna just run this anyway. But because we have two things listed here, when we call the function, we should also have two things listed here. And these are not supposed to be variables, they're supposed to be values. So if I said like 22 and Joe or something like that, I should write this the other way if it's going to make sense, but it will still work properly. So what's going on here? Well, let's flip this around so it makes a bit more sense. We'll do Joe and 22. This is saying that when I call log hello, the first variable that's defined in log hello's parameters, I want to be Joe. The second one, I want to be 22. So it's going to say, well, log hello has this variable we called name. And you'll notice we didn't say let or var or anything for parameters. We don't need them for parameters. So it's going to say we're making a variable called name, and then we're making a variable called age. And I want this name variable to be Joe, just for this one time that I'm calling log hello. I want it to be Joe. And I want age to be 22. So then inside of here, instead of saying my name, what if I just said like my name is, and I'm gonna show you how to add things to a string. If I wanted to add more text to this, all you have to do is use a plus sign and then put whatever you want to add. So I'm going to say floaty boat for now. So when I refresh this, now it says my name is FloatyBoat because I did my name is, and then I added FloatyBoat to it. You can also do numbers. You can say 3. If I refresh this, it says my name is 3. My name is 3. The reason it doesn't look at this like, let's say, 5 plus 3, if I did that, it says 8. It's evaluated this and then wrote it, right? The reason it doesn't do that is because you can't do a math operation on a string. It doesn't make sense. So it's identifying that we have text inside of this operation, and it's saying if text exists, then we're just going to slap new things on the end of the text. We're not going to try to do any math with it. But what we can do now that we have this, what's called concatenation, it's a really long word to say you're putting two things together to make a string, is we can put the name of one of these parameters. So we'll say name outside of quotes. This isn't a string, it's a variable name. We're going to save it and we're going to run this. It says my name is Joe. Well, where'd Joe come from? I don't see Joe anywhere here. Oh, Joe's right here. So when we call log hello, it puts Joe inside of name for just this one time we're running this. And then it says, well, my name is, go fetch what's inside of name. Well, Joe's inside of name. So my name is Joe. My name is Joe. And then we can say, like, let's do another line. I am age. Let's add another concatenation. Years old. How about that? Let's refresh. My name is Joe. I am 22 years old. 22 came from here. It went into age, and then we unpacked age and put it between I am and years old. So now we have a way of saying my name is Joe and I am 22 years old without writing all of this stuff. So what if I want to do it again for somebody else? I can say log hello for Susan. And Susan is 30 years old. Refresh. My name is Joe. I am 22 years old. My name is Susan. I am 30 years old. So you can see again, we're doing the same block of code over and over and over again, but this way we're able to change it a little bit when we choose to do it. And that's the power of parameters. Is I can do this, 50 times or whatever, and I can just change the little bits of values that I'm sending in here, and it'll change what the text is saying. You can do the same thing for, let's say, like addition or subtraction or something. I'm going to say num1 and num2 as my parameters. And then I'm going to say console log num1 plus num2. And let's just change this to be like sum. Okay. Now I can say sum because that's the new name of our function. Open the parameter area. And I need a number. Let's go with 7. And then we're going to need another number. Let's go with 10. Now, what's this going to do? Well, we're going to refresh and we get 17 because it's taking number 1, adding number 2, and then it's printing what the result was. So it's taking 7, it's adding 10, and we're getting 17 printed out, which means we can also do like sum of like 10 plus 20, right? So now we get 17 and 30. So quick way to make like a little calculator function And you can make this really complex. You can do like aerodynamic or physics or whatever like calculations and just put all of the math logic inside of here and then give it a name. So you can do really complicated functions um, for like math, like operations, and you can call it very easily and only give it the numbers that are going to change. So very, very, very useful. There's one more thing about functions that we've glossed over for as long as we've been going. It's called return. What does return do? Well, if you don't put anything after it, it doesn't do anything. I can run this and it's literally just a dead line of code. It doesn't make a difference. But return essentially means I'm done running this function. So if I put this after this and I said, do you see me? You'll notice we never see do you see me, even though we've run the function twice. If I put this after do you see me, now we do see it because we're quitting after we've written this, not before. So that's a super simple way of using return. Let's get into a more complicated way of using it. The point of return is I want to give a function some values, like 7 and 10, the same way that we've been doing it into num1 and num2. But I don't want it to just write the number to the screen. I want to like set a variable equal to whatever this 7 plus 10 is, right? Well, if I print it to the screen, so I'm just gonna rewrite what I had essentially, and I say like let um what is it? Can't think of the word. Whatever. I'll just call it value. If I say like let value equals the sum of 7 and 10, and then let's console log value, refresh, you see undefined. Why does it say undefined? Well, here we're doing sum, so it is running and it's going to print out what the result is, which is 17. But that 17 isn't getting stored anywhere. It's just being written to the screen because we told it to right here. So the reason we're not able to set this equal to value is because sum isn't returning anything. And that might not make a ton of sense right now, but let's just look at it this way. What if we return num1 plus num2 and we save and we refresh? Now we have 17 and 17. We don't want it to just like print it to the screen, right? We wanted it to be stored into this value and then we'll print the value later. So let's just delete this bit and we'll just return num1 plus num2, which is 17. And we're seeing it because we're logging it here. If I commented this out, then we don't see anything. But this is being set to 17 now because we're returning the two values added together. And you can do this similarly with other things. So let's do a string. Let's say hello and world. And then I'm going to say like concat. So we'll call this concat word1, word2, word 1 plus word 2. Okay. If I refresh, I get hello world because we're taking hello's here. We're concatenating world, world, hello world. That's being returned, which means this whole thing is going to be equal to word 1 plus word 2 because that's what we're returning. So then value is going to be hello world. And then that's stored in memory. So like I said, if I'm not logging it, we don't see it. But if I log value now, we get hello world. So return is a way that you can process a bunch of information and just get whatever the result is and then store that result in another variable. So that's just what it is. If you don't need to just visually do something, you just want to keep some numbers crunched in the background or some text like concatenated or something, some kind of background work that you want to do, then you can just return whatever the result of it is and store that into a variable. And that is like the power of functions. Let's talk about objects. We're not going to get too deep into it because objects are like a super complex, like giant ball of yarn. But we're going to go over some of the basics. We're going to say let, and I'm going to say player, like a player of a video game, or like the main character. Let's say main character equals, and I'm going to do a curly brace and close the curly brace and do a semicolon. Now this is very much like how we did this array up here that's just been sitting up here this whole time, right? But we're using curly braces instead of these square braces. And then I'm just breaking it to a new line because I think it looks better. So this creates an object. An object is very similar to an array, but the difference is if I broke an array to different lines, it would look like this, right? An object is the same thing, but you can name these things. So we're going to say like X position colon space 22. Y position colon space 66. Um, we'll say like player name colon space, and then let's just name the player Floaty Boat. I'm the main character, always have been, always will be. So then we'll just say hungry colon space false. So the main character is not hungry. Okay? Easy way to recognize that. So you'll see we have the same values, but now we have names for the values. And that is very powerful if you want to store, again, multiple values into one variable, but you want to access them by name instead of position. Because as an array, we saw this is 0, 1, 2, and 3, right? That's the indexes. An object doesn't have indexes, it has keys and values. So you're going to say main character dot expose, and that's going to be equal to 22. So let's take a look at that. If I say console log, and I say main character, instead of using square braces, I'm pretty sure you can use square braces. We'll try that in a second. We're going to do a period or a dot, whatever you want to call it. And then we're going to say whatever the key is that we want to access. So I'm going to say XPOS. Write it exactly the same as you wrote it in here. And we're going to save it. We're going to refresh. And I see 22 because we went inside of main character and we found the X position box, X position, and inside of that box was 22. So then we just pulled that out and logged to the screen. So now it's 22, right? And you can, if you just want to see all of it, just do main character. And when you refresh, it'll show you all of the values with all their names written out like this. But that's not as useful because you can't often do things by just having a giant list of variables. You usually have to target things individually. So, what can we do with this? Well, outside of our variable declaration, we can change values the same way that we did like for other variables. We can say main character dot x position equals, I'm going to say 100, save, refresh, and now you see the x position is 100. You can do like addition, subtraction, all that stuff, right? I'm going to go backtrack a little bit. Let's try that square bracket thing. If you do square brackets and then in quotes, you say expos, which is short for exposition, save it, refresh, it does the same thing because we're saying instead of the index of the object, we're going to look for the key called expos. So expos. But this is more generally, more often written as dot expos instead of the square brackets. Because the square brackets usually mean you're working with arrays. So if you're using square brackets to interact with objects, then it can get really confusing. So we use this dot syntax instead most of the time, because that lets you know that this is an object and you're accessing this attribute of, or that key attribute, whatever you want to call it, of that object. Okay, so that's really cool. And it allows us to store multiple variables that have to do with the same object. So my X position, my Y position, my name, and whether I'm hungry or not. Where an array is usually just a list of random things that we're usually only managing for a temporary time. An object is usually around almost indefinitely. There are exceptions, but oftentimes we want to keep this around. We might change the values, but we want main character to be around for the entire game, right? So that is how you make an object in JavaScript. Now, what should we think about next? Let's jump a tiny bit back into HTML. After our canvas, let's make a P or a paragraph, as we talked about before. We're going to say this is a paragraph. If you want to comment in HTML, you do a less than, an exclamation mark, two hyphens or dashes, and then to end it, you go to the end of your comment. You're going to do dash dash greater than. And you can see in my editor, it's colored it green. That's why I like Notepad++, is that it colors things for you. But now we know this is commented out, so the canvas is not going to show up on the page anymore. I'm doing this because we want to work with this paragraph we just made. And so I just commented it out for the second. Now we're going to give this paragraph an ID, the same way we did with our canvas. We're giving it a name, and we're going to say my para is short for my paragraph, which is going to be this text, right? What if I want to change the text inside of this paragraph, but I want to change it after the page loads using JavaScript. Well, there's a special way that we access HTML elements, is what they're called. These are elements using JavaScript, and it's by essentially setting them equal to a variable and then interacting with that variable. So we're going to say let my para. We can call it the same thing because it's a different language that we're writing it in. We could also call it like my para 2, my para temp. You can name it whatever you want. It doesn't have to be the same. But I'm just going to name it the same for now. I'm going to say equal to document dot get element by ID, and I'm going to say my para. Now that sounds like a bunch of nonsense. Okay, I understand that. Document is a keyword that we have in JavaScript inside of the browser that means from our page, from our web page that we have, I want to get an element. Well, I said these are elements, right? Both this paragraph and this canvas and any other like HTML thing with tags is an element. So we're going to get an element from our page. We're going to get it by its ID. Well, we gave it an ID here and we called it myPara. Well, then myPara is the ID that we're looking for. So this is saying on our page, we have an element called myPara. I want to grab that and I want to put that inside of my variable. So that's kind of weird, right? Doesn't do anything yet, but we have a reference to it now. We have a way of accessing this from our JavaScript. So there's a lot of different things that you can do with different elements, and you're going to have to kind of look that up if you want to interact with your HTML a lot using JavaScript. We're only going to do it a very minimal amount. I just want to show you this bit to show you like how JavaScript can interact with your page to begin with. So I'm going to say my para, which is this value, this variable that we made here that points to this paragraph. I'm going to say dot inner text, and I'm going to say new text like this. So I'm saying the paragraph that we have, the inner text, or the text that's between the tags that we made, right? The opening and closing tag, the text between them, I want it to be, I think this is actually supposed to be an equals, like this. I want it to be new text. So now when I refresh the page, we see new text on the page. That's crazy, right? Because normally when we write text or something in JavaScript, it shows up in our console. It doesn't show up on the page, right? So that's crazy. You've jumped from JavaScript land to HTML land. And this works even if your console isn't open. We can refresh and it still says new text. But why? Because we already have this text here that says this is a paragraph. If I comment this out, that element already exists. So we don't have to add anything to the page. We're just modifying something that's already on the page. And you can dynamically add things and remove things from the page. That's a bit more complicated. Again, we're not really going to go into it. It doesn't really have to do with game development um, as far as what we're working on right now. But you will get there eventually, and it is pretty useful for certain projects. Okay, so now you know that you can interact with the page, right? And how did we interact with the page? Well, we grabbed the thing that was already on the page and then we did things to it, right? That's what I'm trying to show here. So what if we get rid of this paragraph here, we uncomment our canvas? What if I say my can, short for my canvas, and we're going to get canvas ID instead of paragraph. So now we're making a variable and we're pointing to an element with an ID of canvas ID, which our canvas has an ID of canvas ID, right? You see when I highlight it, the CSS points to it. This is its ID. This is what we're trying to grab, right? And we're storing it inside of my can. Let's do some things with this canvas. We can say my can dot style dot background equals yellow. Okay, that's cool. I made the background of our canvas yellow. That's not exactly what we're trying to do. We're editing the actual element, the let's say the window of our game here. And when you what's something I can open real quick? Um, maybe XAMPP. This should be fine. Okay, so we have XAMPP here. You don't need to know what it is. You don't need to know what it does. You're just like I'm using it as an example. So we have this window for XAMPP. It's got our maximize, minimize, like cancel out buttons at the top right. We have this window. I'm saying that I want this Windows background to be yellow, which is cool and all, but I'm not really editing anything inside of this window. I'm just editing the window itself, which is essentially just the title bar. And I don't want to draw things on the title bar. I want to draw things inside of the window, right? Hopefully that makes sense. So I need a way of accessing the inside of this window instead of accessing the window itself. Okay. So what we're going to do is instead of accessing the window itself that we've called myCan or canvas window, I'm using it kind of interchangeably right now. We need to get the context of this window canvas, whatever you want to call it. And I want to get the 2D context of it. That means inside of this canvas window, whatever, inside is the context. So I want to get the context and I want to use it in a two-dimensional way. There is a three-dimensional way, and there are several other ways of interacting with a canvas. We're not going to get into it. It's complicated, and you can do quite a bit just using the two-dimensional way. But we need a way of referencing the inside so that we can keep accessing the inside easily. So let's just make another variable. I'm going to call it, a lot of people call it CTX for context. I suppose we can do that. And then that will allow us to access the context of this. You can also chain these together. So instead of making two variables, I could say let ctx equals document.get element by ID. Yes, I misspelled it. And then I would say canvas ID. And then here I could just say dot get context 2D. Done. That way I have one variable that points directly to the context inside. So I'm going to do it that way just know that I'm doing a shortcut way to save space. And I'll put that at the top here. We're gonna go down a little bit. And we're gonna just make some random stuff, I suppose. Let's make a object. We're gonna call it player. And we're gonna give it some values. I'm gonna say x is 0, y is 0, width is 50, and height is 50. And then we'll even say like color of blue. Okay. We just made an object. It's got some values. It's just a random thing. Don't worry about it. The color is a string, so don't mess that up. Let's make a function. We're gonna call it game. Let's call it update. There's no parameters. Function. We're gonna say render. No parameters. Function. Game. No parameters. Okay. A bunch of functions that don't do anything if we call them. Object we're not doing anything with yet. And then I'm going to introduce a new predefined function that your browser already knows. It's called set timeout. Okay. Set timeout takes two parameters. It has a function name. So I'm just going to say like game. And then it has a measurement of milliseconds. So if I say 1000, that's 1000 milliseconds or 1 second. So let's do 3. And what this is going to do is it's going to call the game function, this function, but it's only going to call it after the page waits for 3 seconds. That's what set timeout does. So if I say console log, then when I refresh the page, there's nothing. But after 3 seconds, it says hee hee. So we're going to refresh it again right now. That's 3 seconds later. I didn't touch anything. Now it says hee hee because we waited 3000 milliseconds or 3 seconds. And then we ran game and game logs hee hee. So that's super cool. It only happens one time though. What if I want it to happen multiple times? Well, I can say set, I'm blanking, set interval instead of timeout. Same parameters, it's the function and how long I want it to wait, but set interval after it runs game after waiting for 3 seconds, it's going to do it again. So it's going to wait for 3 seconds and run game, and wait for 3 seconds and run game, and wait for 3 seconds and run game. Basically, it's an infinite while loop, which I told you not to do. But this one sleeps, is what we call it. It waits for 3 seconds before it runs the code inside again. So it's not going to lock up our browser and cause issues. So now if I refresh, there's nothing. We wait 3 seconds. It says hee hee, we wait 3 seconds. It says hee hee, we wait 3 seconds. It says hee hee, and it will do this infinitely. But you can see my browser's not freaking out because we're allowing it to take a breath every 3 seconds after it runs it, right? So that's really, really cool. You can also just put a function just directly inside of here, and you can do things like that too. I often do it this way more often than not because it just saves room in the long run. but it's fine. And don't do this. I know that usually when you call a function, you do the parentheses to call the function. Do not do it unless you have parameters that need to go in the function, which you can do, but because you're putting it in set interval, it's kind of weird because you're gonna always be doing the same parameters usually. Anyway, I'm just gonna do an external function like this and call it game. And we're gonna do it every 3 seconds. Game is gonna be super simple. We're gonna say update render. Why would I do this? Well, I have a bunch of logic for the game that I want to happen before I draw things for the game. So this update function is strictly to do behind the scenes math before we draw anything to the screen. And then render is strictly for putting things on the screen after we've done our calculations. So this is a super simple way to just kind of break it up, make it easier to read. You know what's happening before what else. Um, but yeah, oftentimes I do just stick this function inside of set interval and then, roll with it like that. So now if we go to update, I can say console log uh, hello, something like that. And then like console log rendered, something like that, right? When I refresh, we wait 3 seconds, we get hello rendered. Wait 3 seconds. Hello rendered. It's always going to happen in that order, which is what we want. And it's saying hello and then rendered because we're doing hello and then rendered every 3 seconds. Super cool. We're going to need this to happen a lot more frequently. This is essentially where we're setting our frame rate and our tick update rate, which is essentially how often your game is going to update its game logic. So we're going to say 1000, which, as you know, is in milliseconds. That's 1 second, divided by, and we're going to say 60. Why? Because that means 60 times per second we're going to run these functions. So 60 times per second, we're going to update and then render, which means you should have roughly a frame rate of 60 frames per second, 60 FPS. That's the rate that we're trying to run our game at. So if we just refresh now, you see the scroll bar get super long. It's just firing out this text like crazy. It's okay, but we really should stop logging this stuff. It's just crowding our console, creating a lot of nonsense. Okay, cleaned it out. We're all good. This is still running 60 times per second. We're just not seeing anything down here. So now we need to talk a bit about rendering. So we made this ctx variable up here, and that points to the context of our canvas, right? The inside of our canvas. Well, I want to draw something inside of our canvas. Well, all the drawing stuff should go in render, right? We can put it somewhere else, but because this is part of our game logic stuff, we should put it inside of its designated function just to make sure everything's all tidy. So we're going to say ctx. Again, that's what we named our variable. We're going to say fill style equals blue. If we refresh, nothing happens. Why? Because this is like in an art program when you're like selecting a color in the color wheel, but you haven't drawn anything on the screen yet with your paintbrush. So you still don't see anything, you just have blue selected. So now let's actually draw something on the screen. We're going to say ctx dot, we're going to say fill rect. And then this is going to take some parameters. Let's just say 0, 0, 30, 30. Okay, let's see what that does. Well, now we have this blue square. That's weird. Well, the reason it's blue is because before we drew it, we chose the color blue. If I changed this to red, now the box is red. So that's pretty cool. And then it's fill rect. Rect is rectangle. Fill means we're doing the inside of it, which is why all of it is red or blue. And then these are the coordinates inside the canvas that we're drawing it. The thing that's fun about canvas and graphics coordinates is it doesn't follow our normal grid system in math. Y goes up, it increases going downwards. But X still increases going rightward. So this right here is 0, 0. And like here would be like 0, 300. And then here would be like 300, 300. Okay. So let's kind of show that a little bit. If I go 100x and 300y, and then this is width and this is height, it's the same, which is why this looks like a square. I can even change this to be like a little bit off just to show. Now we're going 100 pixels in to the right. We're going 300 pixels down, which gets us this corner here. And then we said it's 30 pixels wide and 40 pixels tall. So that's how this box ends up here. And yes, you can draw it off the screen, and that's like a problem that you're gonna have to deal with. So you're gonna have to do some math to manage that stuff. But for now, let's just go back to 0, 0. We'll do like 50, 50, okay? So you have this big square in the top left corner because it's at 0, 0, and it's 50 width, 50 height. Now, there's a couple other things that you could do. You could do like ctx dot draw string. It's like hello. We'll do it at like 100, 300. And when you do this, I guess it's fill string. Fill. It might be fill text. Give me a second. Yeah, it's fill text. Text. Okay. So now we see hello. It's written really small and like all that stuff, but that's okay. And it's written in blue. The reason it's blue is because we still have blue selected here. You can change the color after you draw something. So I'll say like red. Now the square is blue and the text is red because I did blue, drew the square, then red, then drew the text. So you can do text. You can set the font, all that stuff. And you'll be able to find that in the JavaScript section of W3 if you're looking at the canvas stuff. If you ever can't find something that you're looking for in W3's like side panel here, you can always just open Google and just say like HTML, JavaScript, Canvas, W3 schools, and it'll say HTML canvas graphics. Well, that looks like what we're talking about. Let's click on that. And then it'll take you straight to the page. And you can see here's this stuff. Here is line to and move to and stroke, which are other things that you can also do to this CTX variable, right? Or you can draw a circle using paths and arcs and stroke. And you can fill text like I just showed you. You can set the font so you can make it bigger and choose what font you want. There's tons of things that you can do with this, right? And that's just a quick example of like if you can't find something in here, you can easily just Google it and just include W3 schools in the Google and it'll take you straight to the page you're looking for. But mostly you can just go through these pages and you should find most of what you're looking for. But yeah, so that's like text. We're not going to deal with text right now. It gets a little complicated when you get really into it. But let's change some things, okay? We have this player object. What if instead of writing these numbers, we wrote the player's numbers? So I said like player.x, player.y, player.width, and player.height. That looks interesting, right? Technically it should be the same values we had before, so it doesn't really make a difference. It's still placed the same place, same width and height, but now it's written differently. And if I changed something, like I said, the height was 30 now instead of 50, then when we refresh, now the graphics are automatically adjusting to this object that we changed, which is what we want. So let's go back to 50/50 and refresh. Okay. Um. You know what? I'm just gonna run to the bathroom real quick. I'll be back. All right. Sorry about that. Where were we? Okay, so now we can change these values and it will automatically change how it's being drawn to the screen, right? So what if we know that these are running 60 times per second? What if inside of update I said player dot x plus equals 1? Now we have this like infinite loop thing going on. So I'm saying take whatever x is and add 1 to it, right? Well, if I refresh the page, you'll see we're getting this like loading bar. That's really weird, right? Like, shouldn't the player just be slowly moving to the right? Why are we getting this huge bar until the page is full? So that's something you need to understand about graphics. If you draw something to your screen, it's permanently on the screen until you decide to delete it. So what we're going to do to delete it is we're just going to say before we draw anything, just ctx dot clear rect. We're going to say 0, 0 until 800, 600. Okay. Now when we look at it, it looks more like what we were expecting. The player appears to slowly, 1 pixel at a time, 60 times per second, be moving to the right until he goes off the screen and we can't see him anymore, right? So that's really cool. And how that's happening is kind of an illusion. We're clearing everything inside of our canvas because I said at position 0, 0, which is here, from width 800 to height 600, which is the size we set for our canvas, I'm saying delete everything inside of that rectangle that we made. So we're deleting everything that's been drawn already. We're choosing the color blue, and then we're drawing a rectangle at the coordinates, width, and height of the player. And then the next time it comes around, it's going to delete everything that we drew again, and then draw the player at his new location because we've added 1 to it. So you're actually getting this back and forth where you're looking at nothing, then you're looking at the square, then you're looking at nothing, then you're looking at the square. But that clear and redraw is happening so fast that your eye doesn't register the clear. Like you do not see that the square gets deleted because this is happening so quickly. If we lowered this, you still would not likely see it because it clears and then draws immediately after. It doesn't matter what your frame rate is, it's always going to do that immediately after the other one. So we can reduce the frame rate. You're still probably not going to pick up on the clear and redraw. But that is an illusion that allows us to create an animation. And animations are the beginnings of adding everything to your game. Because everything in your game should feel alive. It should feel like it's moving, doing something. But as you probably can tell, like we're not pushing any buttons to make the player move. He's just moving right now, right? And we can even say like player dot y plus equals 1 here. And then when we refresh, now he's going diagonal. Isn't that really cool? Um, but we're not controlling it. And that's the problem. So how are we going to control the player instead of having it automatically move? We need to make a key listener. A key listener is a very important part of your game engine. And this entire bit we've been writing here, I would say, is part of your game engine. It's very basic logic that is making things happen but there's not anything particularly specific to your game yet, right? You haven't written a story, like you're not interacting with NPCs or like, doing anything. This is all just to get your game working. So this is all part of your game engine. Let's delete this movement stuff in our update for now. The key listener is a function that is getting called regularly that asks your keyboard or mouse what buttons are being pushed. Because we need to know if you're pushing like WASD, the arrow keys, if it's a mouse driven game, what mouse button are you clicking and where are you clicking it? That whole thing. And so this is where things like this is where people warn you about going to specific websites because as long as you are on that website knows what keys you're pushing. So if you type a password, if you, um, I don't know, type something that you shouldn't, then the website knows what you typed and they can store that in a database without you seeing anything. They have that information. So don't go to websites that you don't trust because they log everything that you're doing as far as like your key presses. There are limitations. Like if I go to this tab, then my tab can no longer read my keys because I'm not focused on this tab anymore. And that is a limitation of it. But as long as I'm on this page, I can have like a little input box that's like, type your password. Don't worry, no one can see it. And like, if you do that, now I have your password. um, so yeah, like be very careful on the internet. I'm going to show you how to make this key listener that can be dangerous if you use it for bad things. So don't use it for bad things. So we know that there are predefined functions that our browser gives us, right? And we also know that there's this thing called document that we were using here that's saying like inside of our page, I want to do something. Well, document has something called on key down. On key down is a function that the document has where if you're focused on the document and you push a key, then it's going to do something. We're going to say this is equal to function, and we're going to open a function like this. That's kind of weird. What's even weirder is we're going to put an E inside as a parameter. Okay, this is bizarre, right? Well, one thing I didn't tell you when making functions is you can say like let my function equal function. And this is the same thing as saying function my function like this. It's another way of writing it. It's the same thing. But the way that we're writing it here, we're not making a new variable. We're calling this onKeyDown function that already exists inside of document. So what that means is anytime that a key is pressed when you're focused on the document, I want you to run this function. And then the E is a special little thing that this function is injecting to our function that is whatever key is being pressed. But you have to manage it in a way that's kind of weird. You kind of have to filter it a little bit. But let's just take a look at it, right? So if I say console log E, yes, you can log pretty much anything you want to, and it'll give you some information about it. Is it helpful information? Not always. But anyway, let's refresh the page. Now we should have this onKeyDown function defined. So I'm going to click inside of the page and I'm going to push the D key. Well, that gave us this like little blurb thing that looks like an object, right? I can open this up and I can see all kinds of information about this keyboard event. E is this keyboard event. And keyboard event has a lot of these keys, and the keys have values, right? The values are the value that it was at the time that you pushed the key. So we have Alt key false. I assume that means are you holding the Alt key at the same time that you pushed the D key? No, because all I pushed was the D key, right? We have code key D. That must be the name that they've given it, right? We have a character code called 0. That sounds kind of interesting. We have a key and we have a key code. So key is D because D is the key that I pushed, right? Key code is 68. So what is this 68? Well, every key on your keyboard actually has a number that's affiliated with it. And D's key code is 68. If I pushed a different key, it's going to be a different number. They all have their own individual number that is a way of representing the key. Why is that important? Because if I push D, the key code is 68 and the key is D. If I push Shift and D, then this key is going to be a capital D, but the key code is still going to be 68. And why is that important? Because we're going to be checking what key is being pressed, and if it's the key we're looking for, then we're going to do something. So if I said if E, because E is the keyboard event, right? The keyboard event, dot key, if I said if that's equal to D, then do something, then that's fine. Anytime I push D, it's going to do the thing in here. But if I push Shift D, then I'm still pushing D, but because it's a capital D instead of a lowercase d, it's not going to do what's in here. And you could add something. I forgot to tell you, there's other things you can do in conditions. There's an or, which is two pipes, which is the symbol that's like shift and the key above your enter key. And you can say this or this. So if this is true or this is true, which means only one of them has to be true. You could also do ands, which means this and this have to be true in order to run the code inside. That's two of the things that I didn't really talk about. But anyway, you could say if I'm pushing lowercase d or I'm pushing uppercase d, then run this code. That's an okay way of doing it. I think the better way of doing it is just saying if e.keycode is 68. Right? Because then whether you're holding shift or not, it's always going to detect that it's D. And then we can just do like a little comment here that says D. So we know that 68 is D, right? So we're going to log e.keycode instead of just E. And we're going to refresh this page. I'm going to push D. We see 68, right? Well, I also want WANS. So I'm going to do WANS, just tapping them. Don't hold it. And we see 87, 65, and 83. Those are the keys for WANS. So I like doing W first. So we're going to do 87 is W, A is 65, and then S, I like after W, and that was 83. And then we can get rid of this. And we're going to say console log W. And then we're going to copy this, paste, 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 W, S, A, D, save, refresh. Now when I say W, A, S, D, every time I tapped a key, it did it, right? But if I hold a key, it's going to keep spamming it. And anytime I push a new key, it's going to stop listening to the other key, which is really annoying. So we need to make kind of like a toggle. So we need to say, let's make another object. We're going to call it controls. And we're just going to say left, right, up, down. Okay. Left is false. Right is false. Up is false. Down is false. Okay. And then if we are pushing W, then we want controls dot up to be true. And then we want S controls dot down equals true. Controls dot left equals true. And D controls dot right equals true. Okay, this means when we first push this key, then we're going to say we are now pushing up. We should be traveling up, right? When we push down, we should be heading down, right? And it's just going to toggle these when we push the key. So then in update, we can say if controls dot down, because that's going to be true or false, right? If controls dot up, and we're going to keep going with this with left and right. Then, well, if we're holding up, we want the player to go up, right? Well, up is minus in the y direction, right? Because y goes up in graphics. So we want to say player dot y minus equals 1, right? And then down is going to be the same thing but opposite because we're going down the screen. And then x, if we are going left, is going to be minus, and right is going to be plus, right? So that's cool. Let's refresh the page. Nothing is happening. I'm going to push D. I just tapped it. Now we're heading right, okay? Now, if I type down, now we're going down too. It's like we're holding right and down, right? We have a little problem though, because I tapped the key and I'll release the key and I'm still heading in that direction. So if I want to stop heading in that direction, then I need to know when I release the key, right? So we're going to copy this exact thing and paste it again. But instead of on key down, we're going to say on key up. It's the opposite of on key down. When you push a key down, that's on key down. When you release it, that's on key up. So then instead of saying true, whenever these key codes happen, we're going to say false. And we can just paste that into all of these things, right? So now when we push the key down, it will say we're heading in that direction. And when we push the like the key up, then we'll stop going in that direction. So when we refresh the page, now I can hold D, and when I let go of D, we stop moving right. Hold S, let go of S, A, W, So now we can move, and I can like combine directions so we can kind of head out diagonally, right? That's really cool. Now let's go to player. Let's add another value. We're just going to call it speed, okay? I'm going to set it to 5, I guess. So instead of in update, us going up or down, left, right, 1, why don't we go up, down, left, or right, player speed, okay? Because I don't know how fast I want the player to be able to move. So let's just change it so this is all the same. And if we ever want to change it, we just have to change it here. If I refresh, now we're flying. We're jumping all over the screen, right? And there's going to be a combination between your frame rate and the number you choose for speed that's going to make this animation more or less believable. The higher frame rate you have, theoretically, the faster you should be able to move. But the way that we're writing the game right now, our update and our render are tied to the same loop. So that's not actually going to be true. In the future, I can show you a different way of doing it. I believe I already have in one of my streams. If you want to check the channel, I should have a playlist for web development games. If you want to check that out, I just live streamed a million different things that you're going to need to know. So if you really just want a reference and to get a more thorough explanation of a lot of this stuff, just go check out the streams. Very informative. I tried to be very base level so everyone understands what's going on. And this is more or less a tutorial to get you to where you can watch the streams. So we also have this color blue. Instead of fill style blue, why don't we say player.color? Again, just like what if I just want to change this to red and then now my player's red, or yellow, now my player's yellow, that kind of thing. You want to, as much as you can, make it so you only change one value somewhere and it'll update it across all of your code. So that's what this is really useful for. But yeah, so now we have this player and the player can move around, which is really cool. And that, let me think, let me think, let me think. I taught you that, I taught you that, I taught you that. Yeah, believe it or not, I've taught you everything that you need to know in order to A, teach yourself more. Like a lot of it is just W3 schools. And any time that you need to know how to do something, like if you have an idea in your head about what you want to do, like what if I say like add CSS border to canvas, right? Just Google it. A lot of times the AI is going to say like, well, you have this canvas here. Why don't you just add this style tag that's a 2 pixel solid? This is white. That's hexadecimal way of saying white. Don't worry about that. But this is like, well, this is an easy way to do it. Inside of your canvas, you can just write it right there. Or for an external CSS, then you can do this stuff. See, this is more like what we wrote up here, is that kind of layout. Um, or you can use JavaScript to do it too. So, there's a bunch of different ways that you can learn how to do the things that you want to do. Honestly, just anything that you want to do, just Google it. Make sure you include the language you're trying to do it in. So if you're trying to make something prettier, say CSS. If you're trying to add more things to the page itself, then do HTML. If you're trying to add things inside of your game, then write JavaScript. And generally Google will sort it out. Sometimes you'll have to go to like Stack Overflow. Stack Overflow is pretty good. They have good answers, but rude people. That's just kind of how it is. But if you cannot like find what you're looking for just by Googling it, then you're probably gonna have to dig through some of W3 um, like links and see if you can actually do the thing you're trying to do, or if you're gonna have to get really creative about it in order to accomplish what you want. But yeah, that is genuinely um, like from scratch how you make a game engine. And this is the point that I would call it a game engine because we have a way of listening for controls. We have a way to draw it to our screen using our canvas and our render function. And then we can interact with it using like we have this player kind of placeholder and we can tell it to move up, down, left, right, all that stuff. So this really is, and like we have a frame rate. So like, yeah, this is like genuinely a game engine at this point. And that doesn't mean that you're done working on your game engine. It's definitely not finished. You're going to be adding more if you want your game to be able to do more. But like you have a working engine, you can do things, and that's kind of the point of having an engine. um, Things like adding the ability to have audio, adding the ability to add images, things like that would be like extending your engine. Just adding an image or adding music or something to your game would be adding to your game code because it's not extending the ability that your game has. It's just adding things for your game to do. But yeah, this did end up being quite a bit longer than I expected it to be. And I feel like there's probably more I could have showed you how to do. But if there's any questions that you have about like how some of this stuff works, or maybe you're trying to do something that like you can't quite figure out how you can do it, like Google's not helping, you can't find things on W3, um, then you can go look at my channel and check out the streams because most likely I've covered it in the streams. I covered pretty much everything I could think of on my streams. So if you watch all the minutes of my streams, if you hit a Java section, you can skip the rest of the stream because I've switched languages at that point. um, but like I should have covered pretty much everything you need to know about making games in both uh, HTML, CSS, JavaScript, and in Java, which again, to kind of go back on, are two different languages, Java and JavaScript. They are not the same. But yeah, so I'm going to leave you at that. Um, as I said, just leave a comment if you need help or something. But yeah, this has been Floaty Boat. Quite a long video. Probably could have just made another stream or something, but that's cool. I will maybe talk to you all later. Peace.